Hello, amazing hackers. Are you looking for a place to learn how to hack? Check it out labs.hackexpert.com, a free training platform provided by Cross-Site Scripting Hat with over 150 unique exploits and labs that emulate real-life applications. Check out the Cross-Site Scripting Hat on YouTube if you want to have some guidance with the labs and hack in general. And don't forget to use my special discount code with 17 off everything always. Hello everyone, welcome back to our 19.io podcast. Today's guest is someone who has quietly influenced how thousands of security engineers learning web exploitation. Lowy is the founder of PentesterLab, one of the most respected platforms for learning web hacking through hands-on exercise. But before building PentesterLab, Lois worked in trends doing penetration testing, code review across multiple languages, and security engineer for large organizations. So today I want to go deeper than a typical interview. We go in talking about how vulnerabilities are actually discovered in code, how real attackers thinking when chain bugs, and how developers and security engineers can training their brains to see vulnerabilities faster. Lois, welcome to the show. I really appreciate your time, and please say something.
Thanks for having me. That's my pleasure, really.
Okay. That's really interesting to have here. I always like to start from the origin story. Most people who get into offensive security usually start with tools, scanners, maybe burp suite or metasploit. But when I look at Pentest Labs, I feel it feels like it came from someone who really understands how vulnerability exists inside the code, not just how to exploit them. So I'm curious, how did you personally transition from learning security to actually thinking like someone who read codes and see vulnerabilities immediately? Was there a moment where things clicked for you?
Um, so I kind of never had to do that transition
Mm.
because I went to school and went to engineering school and I basically have a degree in computer architecture.
Hmm.
So I have like a formal training as basically a developer. So for me, finding bugs in code has always been like the way to go. And I think my background as an engineer really
Hmm.
gave me like the foundation to um, trying to understand systems and trying
Hmm.
to not thinking about breaking them, but thinking about understanding them first and then breaking them. And I think that's an approach that is really helps when you are looking for deeper bugs, like bugs that a scanner may not find, or bugs that are harder to find. Um, it's really like a change in mindset. It's like, let's understand how this works, and then we will think about security, as opposed to like just like let's find bugs straight away.
Yeah, yeah, for sure. That's interesting because code review is something many pen testers struggle with. A lot of people are comfortable sending payloads to an endpoint, but when they open the source code of an application, suddenly they feel lost. And from your experience, uh, doing security code review across languages like Java, JavaScript, and mobile code, what are the mental patterns that experienced reviewers developed? What are they actually looking for?
So I think one of the first thing, if you come as a pen tester, one of the first thing you need to change is, again, like a lot of people coming from pen test think they're going to approach code review like they approach a pen test, and they may like start a scanner and see what comes back. And a lot of people doing code review don't read code. They read the output of the scanner or the output of grep. And that's again the same thing, is like you don't spend the time understanding the system. So you don't, it's harder to find bugs. And I think like it's incredibly frustrating to do triage of findings from a scanner. You're like, most of the time you're wasting time because like a lot of them are false positive. Some of them as well, you realize that they may not be exploitable, or there may be like some side effect, and you don't learn that much about the application, and you don't learn that much as a reviewer as well. You don't
Yeah.
feel like you had like a productive day because you're just sorting things, right? Where
Just
if you spend,
running those. Yeah.
yeah, if you spend time understanding the code base, um, regardless of what you find or don't find, at the end of the day, you're a little bit better at code review. And you're a
Okay.
little bit better at reviewing this application. And over time, that will compound both in terms of your skills and as a code reviewer, and your skills as a code reviewer for that application. And I think there
Okay.
is most people like who don't like pen test, it's often, who don't like code review, sorry, it's often because they don't actually read code. They don't actually review code. They review the output of a tool. They're so obsessed about being productive, being efficient, that and finding good bugs that they don't find anything. They're not productive and they're not efficient.
Yeah, yeah, that's really interesting. Yeah, one thing I noticed when studying real vulnerabilities is that experienced researchers don't read code line by line. They scan for the patterns of dangers, things like deserialization, templates, rendering, using portfolio into dangerous APIs, file system access, authentication logic. So when you approach a new code base during review, what's your, let's say, what's your first mental checklist? What you do for scan for immediately? You let me know what's your brain works.
So what I do usually is I ask myself a small question. I say like, okay, I don't know, how are passwords encrypted or hashed? And then I
Hmm.
try to find the answer in the source code. And from that, I start to build like knowledge of the code base, understanding of its structure. And if I got enough information based on that, I can move on to like doing like a full code review, or I can say like, okay, maybe I should move to another question and do another simple question like, how do they interact with the database, and see like what library they're using, how they like using it, and little by little you gain this uh, mapping of the code base, and it's not no longer like a big application that you have never seen before with a lot of code. It becomes something you can handle and you can map and you can visualize. And you also, by looking at a few parts of the application, you have an idea of the maturity of how good the developers are, what are things that they don't do really well. And from that, you can look for bugs. Um, I think the approach of going like a sync to source or source to sync is very much also like a vulnerability researcher view of code review. If you're, for example, working in application security, you don't necessarily care about the same thing. You care about vulnerabilities for sure, but you also care about making your application less fragile. So making it harder to hack. So even if you don't find things that are exploitable, you can find things that may be improved. And so this, like, yeah, there are many ways to do code review, and like looking, like just scraping for dangerous patterns and then following the trace to see if it's available, yeah,
Hmm.
exploitable, is just one way to do code review.
Okay, that's fascinating because it suggests vulnerability discovery. It's actually more than like pattern recognition training than brute force analysis. Let's say it's almost like training your brain to detect anomalies. And do you think this is something that can be systematically tough, or is something that only comes with thousands of hours reading code?
So I think it can be tough. That's what I'm doing, at least with PentesterLab, and I'm trying. I think there is a lot of it is pattern matching, is understanding like what to look for, understanding like Spider-Man says, like having your spidey sense tingling when the code is not
Mm-hmm.
right. You know, like you kind of like read code and you're like, okay, that doesn't look great. This is worth investigating. And I think a lot of that you can teach. After that, a lot of that as well is practice, 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 practice. So it's like, I don't know, swimming. You can have like a lot of lessons, but if you don't swim regularly, you're never going to become like a great swimmer. Code review is the same thing. If you do like code review once every 6 months, it's going to be hard to become be a good code reviewer. So it's something
Yeah.
that you can learn the pattern, you can learn how to get better, what things to look for. But if you don't practice, you're never gonna get to like a really good level.
Yeah, yes, I really agree with that. And let's go back, and if you go back maybe, okay, 15 years, the web vulnerability landscapes, it's look at very different. We had classic issues like SQL injections everywhere, reflect cross-site scripting, uh, basic authentication flaws, but today we see more vulnerabilities. It's like server-side request forage chains, deserialization bugs, business logic attacks, supply chains vulnerabilities. And from your perspective, how has the web attack surface evolved over the last decade?
Ooh, that's a good question. So I think it has changed a lot because software development has changed a
Mm-hmm.
lot. So 10 or 20 years ago, people used to write web application in PHP.
Mm-hmm.
And they were doing everything themselves. They were writing like SQL query. They were doing a lot of things that were pretty dangerous. And nowadays, with modern frameworks, they don't really need to do that anymore. Like they have a data mapper that will go like from code to results from the database. So they shouldn't have to write any SQL. Like,
Mm-hmm.
it's really, really rare that you have to write SQL nowadays. You shouldn't have to any, or unless you like crazy like optimization in that, like most people don't have to do. And so you have these modern frameworks that block like basic XSS, they block SQL injection. And at the same time, so that got things in a better place for all these bug classes. But at the same time, application became more complex. We used to have
Mm-hmm.
one big application, one monolith, where you have like the big applications on one server and everything was running on that server. Now, what people change is that they move from that monolith to a lot of microservices, a lot of reverse proxy, a
Mm.
lot of
Wow.
one server touching another server, getting result from another server. And all of those like introduced or created like a lot of possibilities or vulnerabilities around like request smuggling, like path
Yeah.
traversal, because you could like pretend you were accessing one server but redirecting with another one with a path traversal. And all this complexity created like a lot of or made some bug classes more common. Um,
Mm.
and
Yeah.
also at the same time, for example, with AI, a lot of the recent vulnerabilities you can see in GitHub advisories are around
Mm-hmm.
deserialization, because AI models love serialization, especially in Python, and
Mm-hmm.
also around code execution with MCP servers, like a lot
Mm-hmm.
of code execution in command execution and code execution in MCP servers. So that's, yeah.
Yeah, that's really that's I really agree with that, and I'm curious um about something more subtle. Many developers thinking frameworks solve security problems. For example, frameworks like you said sometimes prevent SQL injections, but uh, we still see critical vulnerabilities. So where do modern frameworks actually fail developers?
Um, so authorization often is a hard thing. Path manipulations, because aside from a few languages, most languages don't have really good function or really good libraries to prevent path manipulations like directory traversals and things like that. Um, like aside from like Golang with OS root that really blocks the directory traversal, most languages don't have something that is really good. Uh, Even just like checking that one path is within another path can be really hard. And some languages like Java or Python have function or method that do that, but it's still something that is pretty rare. And the same thing for a domain. Checking that a domain, a host name is part of a domain, or checking that an email address is part of a domain is seems really easy, but in practice, that's often what developers get wrong.
Yeah, yeah, that's really amazing how you think about that. That's really interesting. Give this feedback from that's really interesting. Give this feedback from your perspective because you um, build these labs. You really review code. You already have a big landscape, and let's go. Let's get very practical. Imagine you are performing a security code review of your large web application. Maybe, okay, let's say hundreds of thousands of line of codes. Um, Walk us through your process. Where do you start? So do you map, for example, endpoint first, search for dangerous functions, or maybe trace data flow? How do you approach this methodology? Because okay, let me try to explain this question. Many pen testers or security researchers really are watching this podcast, and sometimes this type of questions usually it's a great insight for many of us, and then that's really interesting. Understand how your brain works.
Um, so, um, so first, it depends on why you're doing the code review. Why you doing like if I want to find one vulnerability, it's not going to be the same job as trying to find all the vulnerabilities or most of the vulnerabilities. Um, like are they part of the application I can ignore because they are behind like an admin login or something like that? What do people care about? Like, if I'm looking for one code execution in an application because I want to compromise it, it's not the same job as trying to do a code review where I'm going to find a lot of vulnerabilities, right? I think what I like to do is, or try to do at least, is for code review, is starting with the documentation and trying to find area of interest depending on what I need to do. And I think most people don't spend enough time looking at documentation. Um, like what functionalities are available in this application and what functionalities are interesting for me as an attacker or as a code reviewer. And then you can go from there and like start looking at what those functionality are doing and what's the code is doing. And if you can find little weaknesses that put together can do something interesting. Um, and I think it's about like, okay, pinpointing like what is interesting, what I want to achieve, and map those two things together to like, okay, this is interesting, but that's not my goal. This is interesting, and that match what I'm trying to achieve for that code review.
Wow. Yeah. Yeah. That's make a lot of sense. Um, because many beginners try to read code sequentially, but attackers think differently. They look for control points when the user input enter system, which brings me something interesting. Uh, I have another question. Of course, I have many questions for you. I really love make questions here for my guests. Do you personally use tools like SendGrab, CodeQL, or stat analysis, or do you still rely heavily on manual reasoning?
So I use a bit of SemGrep. I used to use a lot of SemGrep. Nowadays, I mostly use Cloud Code. Like, I have skills to do code review, and they're pretty good.
That's better.
Uh, yeah, like it depends. Again, it depends on the code base and what you're trying to achieve. Like SemGrep is really great. CodeQL, I find it a bit complicated to set up and use and write rules. Um, um, I find like writing good skills for Cloud Code is pretty efficient at the moment. If you can use Cloud Code, if there is no like some like source code privacy issues and things like that, and it depends as well on what you do using test cases as well. Sometime instead of doing like a code review, you can start writing test cases inside the application and get it to like, okay, let's check all those assumptions. Let's see what is working and not working. And yeah, and you can get even like LLMs like Cloud Code or Codex or whatever you want to write those test cases and then run the test cases to see like if your assumptions are security issues or not.
Yeah, I really love it. I really use a lot of grabs many times. Of course, I don't have the same experience with code review as you, but I'm trying. And then usually when I needed to conduct, for example, static analysis, usually grab is on the top of my tools that I usually use. In the past, I already was a developer, but right now I'm focused on um, security bypass, DR evasions, and stuff like that. And of course, I needed to build codes in C sharp and another language, but code review isn't my focus on, let's say, right now. But that's I put one note here about you wrote about something I find incredibly interesting. That was CVA archaeology. The idea that by studying historical vulnerabilities deeply, you can uncover patterns that still exist in modern code. I think this is extremely underrated. Most people read CVAs as, let's say, red lines, but rarely analyze them deeply. So I'm curious again. When you analyze a historical vulnerability, what exactly are you looking for?
So I like it so much that I wrote a book on that. And
Please.
so we have this amazing knowledge base of all the vulnerabilities that have been published since 2000 or 1998 maybe or something like that. So, and all this knowledge is barely used. Like people look at the risk rating, the explanation maybe of the issue. Some people sometimes look at the exploit, but like it's like people are looking at what the issue was. Most people look at the risk. Some people start looking at the exploit, and few nerds are looking at the source code and the difference. And you can learn so much by looking at what the actual bug was, like what in source code was the issue. So I blogged recently about, like, for example, one example where they moved from SHA-1 to SHA-2 to make, because SHA-1 is less secure, but that increased the size of some data, and that data was going through bcrypt, and bcrypt has a limit at I think 72 bytes from memory, and because they increased that size, the password wasn't verified anymore, and you could log in with any password. And when you look at the advisory, it's like, this application allows you to log in with any password. And if you stop there, you're just like, oh, silly developers, I wonder what they did. Like, and when you dig and you dig and you dig, you like understand so much about like what happened, that they're not silly developers. They just were very unlucky. They tried to do the right thing to make, to move away from SHA-1 to SHA-2. And that bite them like really bad. They got beaten really bad for trying to do the right thing. And that's a really great story. And then you look at the details and you understand, like, okay, they're doing a challenge response. So that's a complex protocol that you like, not really complex, but that's an interesting protocol. And then you learn about the limitation of bcrypt, of the 72 bytes. And you look at all the implications of doing that, and you learn so much more. And that's just one bug. And then if you keep doing that again and again and again and again, you learn a lot. And then you learn how people make mistakes. And also you learn like what matters for application security. For example, this code base doesn't have any test cases around authentication. And if there are test cases around authentication, like I can log in with a valid password, I can't log in with a valid password, that bug would have never existed. And so like, and that's just one vulnerability. It's a pretty cool one, but that's just one. And then if you keep doing that again, and again, you're like build that database of knowledge that gives you like you learn so many new things. And yeah,
usually that's really interesting, because sometimes when you conduct, for example, one vulnerability assessment, usually you can see one CVE, but this CVE doesn't have a public exploit, and then but you have the art code behind that, and you can see the source code, but people don't stop to try to create or to try to understand the code or to try to create one exploit to try to exploit them. Just, okay, let's go to another find, or let's go to another CVE. Yeah. And have you had the experience where studying an old vulnerability directly helped you discover a new one in a completely different project?
So a few things. So often, so you can find like bad fixes. So like probably like a dozen or 2 dozen times a year, I look at CVE, and I looked at one CVE and find a bypass. So like, probably 20 bypasses per year, I would say, because the fix is not good enough. You also often, vulnerabilities are in part of the code base where the code hasn't been looked at for a long time, or that's a developer that wasn't probably as security aware. And if you keep looking in the same zone, you may find other vulnerabilities. And finally, one of the trick of the code review world is you take one CVE and say like, okay, let's look for the same thing in other code bases. Let's look for something in the same language. Let's look for the same thing in another language. How can we translate this Python vulnerability to a Ruby vulnerability? And then let's look for that Ruby vulnerability. And that's because developers often make the same mistakes. So if one developer had a bad assumption, didn't understand something properly, it's likely that this developer won't be the only person doing that mistake.
Just change the language. That's the same vulnerabilities all the
Exactly.
time. I agree with that. And okay, let's go. Let's talk about Pentest Labs.
Yep.
Okay. Pentest Labs is fascinating because it doesn't teach security the way many courses do. Most training programs rely heavily on slides and theory. Pentest Labs is almost entirely learning by exploitation. It's
Yes.
hands-on labs, vulnerable applications, real tech scenarios. So I'm curious about the philosophy behind that. Why do you believe practical labs are the best way to learn security?
So I used to run training in person, and like a very long time ago. And if you explain something, everyone gets it. Like, oh yeah, yeah, that's easy. And then you get them to do it, and they realize that they didn't get it at all, or they are like something that they thought and they understood, but they didn't actually. Or as part of like doing the exploitation, they forget about one little detail. And I think that's like you want to learn on a platform or do a training where you have hands-on element, because you want to make sure that if you're writing script, they work, and you don't want to test that in a production environment or during a pen test. You want to create them like when you're doing training. Um, and like, yeah, I think there's like pen testing is often like a job where you need to have like a lot of tiny details well aligned for an exploit to work. And if you don't practice that, you miss a lot of vulnerabilities. So that's why we mostly do hands-on.
Yeah, I really agree. And designing good labs is actually harder than people think because they must be realistic, educational, solvable, but still challenging. Uh, what makes good security lab exercise in your perspective?
I think the key thing is so what I'm trying to do when I build a lab is having my students to have this haha moment where they realize something and like,
Yeah.
that's what I'm aiming for. And I think that's what makes a good lab. When people understand something or thought they understood something, and then all of a sudden they realize like the depth of what they are really understanding or learning.
That's amazing. That's really amazing. And okay, uh, let's talk the future of web applications or web exploitation, because right now we have AI, we have many ways to analyze and to exploit web vulnerabilities. Let's talk about where things are going. We now have AI generated code, sometimes increasingly complex frameworks, like you said before, serverless architectures, microservices everywhere. From an attacker perspective, do you think the future of web exploitation will become harder or easier?
That's the
Thinking
great
in
question.
vibe code sometimes, okay,
So
maybe.
I think it's hard to tell because we don't know how AI will, if and how AI will become better. I think the thing is that writing code right now is very, very cheap.
Mhm.
So people tend to write a lot of code and put more application out, and So we're going to have more and more applications. And those applications, if the developers are not careful, can have a lot of vulnerabilities. Because LLMs or coding agents do what you tell them to do. And if you're not proactive security-wise to tell them, like, okay, we are writing this feature, do that, security-wise, make sure that, write test cases for those security issues. So we have some base level. They often do something pretty simple and like find an easy way out to get the feature to work. And often that has a lot of security impact. But we're going to have like definitely more and more code. The quality will be all over the place, I think. And we're going to have to automate a lot of the testing to be able to like manage all that code. And a lot of tooling and a lot of, for everything are based on the assumption that the code was written by human. So we will see this type of mistakes. Nowadays, the code is no longer written by humans, or in a lot of cases. So the mistakes will be different. Like the WASP top 10, to simplify, is created for humans. It's not created for LLMs. So what is the OWASP top 10 for LLMs? As in not for the security of LLMs, but for what security mistakes LLMs are making.
Yeah, for sure. Okay. Because I'm right now I'm studying for some AI certifications, and I study more about top 10 LLMs vulnerabilities, or whatever. And that's interesting because you don't you don't have to rely heavily an output that AI give you, and then you need to, and something that concerned me personally is that explosion of AI generated code. Developers are shipping code faster than ever, but often without you fully understand what the code does. And do you think AI will introduce a new wave of vulnerabilities?
Oh, it already does. Like all the MCPs vulnerabilities, like or even like if you look at OpenCloud, the list of CVE, I think it's like the new record of like the project age, like how long the project has been around versus the number of bugs in it. It's like riddled with bugs. And yeah, because again, it's hard to get like, it's hard to be fast and safe. It's really hard.
Yeah.
And unfortunately, because they don't know or because they don't care, some people are more going towards the fast development and less against the safe development. And that has been like the game for like before AI, but now with AI, it's like even more visible.
Yeah, for sure. That's really interesting. And let's go to advice for security researchers. Many people listen to this podcast are security engineers, pen testers, or sometimes aspiring researchers. And a common challenge is they know tools, they know payloads, but they struggle to find to original vulnerabilities. So if someone wants to become a really good at vulnerability research, what should they focus on?
So I think two things. Often after like I would say 3-4 years as a pen tester, or even like or in security or in offensive security, people get stuck and feel like they're not getting better because I think they don't read code. And I think you're at a point where you need to read code to find or to have new ideas of what to look for in an application, or what could be interesting to test for. And I think that's coming from doing code review really helps with that. Another problem people do is that is they want to be good at everything. You can't be good at Windows exploitation, cloud exploitation, web exploitation, and code review nowadays. It's just too hard. It's just too like broad. And if you really want to get good at something, you need to spend your time on one thing. And I wouldn't say even web exploitation. Even web exploitation nowadays is too big. If you want to really be a security researcher, you need to spend your time on exploiting big Java application, or exploiting .NET application, or exploiting Golang application. Because the space is getting too big, and you really need to go deep on those subjects, and then you can move to another subject once you think like you have exhausted that subject. But what people do is that they stay comfortable. They keep learning through like platform, like PentesterLab or other platform, and they never make the jump to like doing their own research, go deep. And they, instead of doing that, they say like, oh, now that I feel that I'm good enough at web, I'm going to move to Active Directory exploitation, for example. But that's not how you get great. I think you can be, if you get great at something as well, the skills you will learn at the top level will apply to other domain. But if you never get in one domain to that top level, to that greatness, you never get those skills. Those skills of like debugging, deep code review, and things like that, that then can move to from one domain to another.
That's really the great advice, because many people underestimate the importance of reading code every day. Security research is almost like learning a language.
Yep.
Your brain slowly learns how vulnerable code sounds. um, and but before we wrap up, I have a final question. After spending so many years studying vulnerabilities, do you still get excited when you find a new one, or does it become a routine for you?
Um, I don't get very excited by finding new vulnerabilities. I get extremely excited by learning something new.
Hmm. Wow.
And I think that's something, and that's why I study a lot of vulnerabilities, because what excites me is like learn something new and then share it with the world. And so that's why like finding a vulnerability is kind of, I wouldn't, it's still exciting, but it's just like one more CV or one thing to report. I'm going to have to like report that, explain to people. It's a bit annoying, but learning something new is just so exciting. It's for me like
That's
that's the real thing. Like having like another CV doesn't really matter, or like another bug. Like
yeah.
just But
This this is like conduct a penetration test and get a domain admin. Yeah, that's okay. I make this every single day, and then this one more. But when you're learning new one, that's really interesting. I share the same feeling. Uh, yeah, and it was really great, Lois. This was an amazing conversations. We covered everything, from vulnerability pattern recognitions to the evolution of web attacks and the philosophy behind teaching security. If people want to learn more from your work, they should definitely check it out. Pentest Labs, which has trained thousands of engineers in the real world web exploitations. And thanks again for joining us today. I really, really appreciate your time. We have here the big difference in the time zone, and I know that your time, it's that's really busy, And please say something to our hackers to close this episode.
So thanks a lot for having me first, and it was really great, and I really enjoy your question, like really interesting questions. And for everyone else, I really think like even if we have AI and things are scary, it's really interesting as time as well. And don't get stuck in like a AI or anti-AI. Just spend time learning, getting better, and like it's with like we're just so lucky to like be working in security and looking at vulnerabilities and things like that. It's just like, yeah, keep it up and happy hacking, I guess.
Yeah, that's really interesting and good. Hear the voice of experience. Uh, that was really amazing, and again, talk with you. And if you wanna learn more about pen testing and code review, please check it out. Pentest Labs. This is an amazing platform, and please follow Lois in a social media, usually in LinkedIn. Please follow there, and please don't miss this episode in the next another episodes. And yeah, was another fucking episode of our 19.0 podcast. Lois, thanks again, and see you in next time.
See you, and
Bye.
thanks for having me.
Yeah, thank you.